Our next session is going to get into the fireside chat, which will be an inside look at Fanuc America Corporation. And so bear with me. We're just going to give you a brief preview of Fanuc, and then we will segue into that fireside chat.
We'd like to introduce you to our purpose-built application, or PBA, on defect detection. In the manufacturing process, many customers contend with quality assurance requirements, as well as changing criteria for the products and materials they produce. With the Ango Hub, iMerit has technology that allows us to create a tailored workflow as a solution for these customers. This approach ensures quicker defect detection through automation, resulting in a more efficient and accurate manufacturing process. iMerit offers a full suite of annotation solutions in one fully integrated and flexible automation platform with state-of-the-art annotation technology and experts in the loop. Typically, client data is set up to sync directly from the cloud to the Ango platform. This can occur as a batched cadence or as an on-demand process via API. Here, we are uploading black and white images of steel surfaces being manufactured. In our example, we'll look at the steel surface ISO for defect detection. Once the files have been added to the project, we're ready to apply the taxonomy. We've customized the taxonomy by adding labels beyond what our model is able to detect to allow for human annotation of welding defects. The workflow configuration tool enables endless customization and continuous optimization with simple drag and drop nodes. These are the building blocks that allow us to support various stages of review, consensus, and automation. We first apply iMerit or the customer's own predictive model to the dataset. A quick review of this by a human annotator will guide the next steps in the process. In this example, a defect was not found in the image, and everything looks okay to proceed. However, if a defect is discovered in the image, the detection model attempts to identify it automatically, which is then confirmed by the annotator. It is also possible that the defect exists, however the model does not correctly identify it. In this case, we create an issue using the issue tracker so that the model can be trained on more samples for future success. If the customer is interested in a real-time system, this can now trigger a webhook, which can be set up to support our customer's ticket system, or to simply send an email to predetermined recipients. With this information, the customer can take immediate action to address the defects discovered. Once the project is completed, our customers will receive a detailed report that outlines which defects were discovered across the dataset, as well as basic performance metrics. Our analytics engine also provides actionable insights that may be beneficial to future work. Our example centered around steel, the steel surface standard, and material manufacturing. But we have had several customers with unique project parameters that we've performed similar tasks for. We believe that with this PBA, we can take our new technology to even more customers in the market.
All right, we're at our fireside chat session for the afternoon, and it's my pleasure to introduce Jeff Mills, who is the president of iMerit. He will be facilitating today's fireside chat discussion. Welcome, Jeff.
Thanks, Chris. Thank you all for joining. As mentioned, my name is Jeff Mills. I am the president here at iMerit, where I've had the pleasure to be partnering with the leading companies in AI now for over 7 years. It's my privilege to be speaking today with the senior lead of robotics at FANUC, the great Laura Evans. Laura, welcome to our fireside chat. I hope it's not too warm in here.
No, thank you, Jeff. Thank you very much for having me, and appreciate the opportunity to be part of this elite team. I'm actually blown away after sitting in and listening through all of the panelists and their experience and their technologies. I've learned so much. I'm absolutely honored to be able to be part of it.
Well, I know everyone's excited to hear from you today. You have such an extensive background in the robotics industry. You've been, working in this industry for decades at this point, really helping take companies kind of to the next level around not just robotics, but robotic automation. You've been, working, I think, at GM over 30 years ago, so you've kind of seen the whole development of the space and how it's kind of evolved. Can you kind of start off by telling us a little bit, with your background, share a little bit of the variety of work you're proud to have worked on to help kind of advance robotic operations and, these last couple decades you've been, boots on the ground this whole time.
Yep. Thank you so much, Jeff. Yeah. So actually, I started my career in robotics as a co-op student way back when in the early 80s. And so I had the opportunity to actually work for General Motors and program some of their spot welding robots. That gave me a taste of it. Did a thesis trying to adopt what I called real-time seam tracking to follow seams on a vehicle car so we could adaptively apply sealers. So stuff that was kind of revolutionary. I kind of joke about this because hearing all this stuff today about AI and vision technologies, it does kind of make me laugh when I think back when I started working with robots and vision. A vision processor to do very rudimentary vision had a controller itself that was larger than me. And now it's just kind of funny to think how far we've come, because now you've got extremely intelligent vision on a small little circuit chip inside of a robot controller, et cetera. So yeah, so kind of to answer your questions, I've had the opportunity then, once I left General Motors and joined into FANUC, to kind of touch on a whole lot of different areas. I know I started more as an applications engineer, which was really fun because again, back in the 80s and 90s, primarily the use of what we call industrial robots were primarily in manufacturing. So it started with automotive and automotive components as being the big heavy users of automation and robotics, but certainly very quickly morphed into consumer products, plastics, injection molders, metals, pharma, pretty much everything. So I have been to just so many different manufacturing plants. And I have to say, that's like the funnest part of my job, is to be able to go to a plant and walk through and do what I call an automation audit and help our customers say, where is the low hanging fruit? Where can you adopt automation? So yeah, that's kind of what my role is now, is more on that side of, even though I wear like the sales hat for business development, what I enjoy about the job is truly helping customers figure out where should they invest in automation, where is it sensible. And as I think, one of the earlier panelists says, a robot is a tool. It's not the end all be all for every application.
Right.
I try to help steer people in the right direction.
It's funny you mentioned kind of the timeline of how things have developed, and you talk about automotive kind of being kind of in the early stages where things developed. iMerit, very similar. We started really with automotive, moving into self-driving cars, and then eventually like the robotic stuff really kept moved into agriculture. Now we're working in healthcare, and all these areas have moved forward. When you and I first spoke, we talked a little bit about how manufacturing really drove a lot of this robotic automation, and then now as warehouses have really started to bloom and move to the next level, they're kind of trying to catch up to what the warehouses, what the manufacturing groups had done in the beginning. Talk a little bit about that kind of development of how you've seen, the warehouses not necessarily copy, but try to catch up and learn from what the warehouses had gone through in the beginning. What manufacturing had gone through in the beginning.
Sure. I mean, I think anyone who's a player in the industrial robot space, we all started in manufacturing, and clearly over the last 10 years, I've just seen our type of robot technology get adopted at truly an exponential rate into the warehouse space. So it's been a big change where, the heavy users were more manufacturing, and you knew what the product you're making was. It was a very more repetitive task adoption of robotics. And so moving into the warehouse space, it's kind of like you had to start all over and help those warehouse and automation and e-com people learn how to adopt robots, which means things like design for automation. We did it in manufacturing. Now I kind of heard some pieces of it earlier, and you saw a lot of the videos where to automate in a warehouse, instead of having all the products that you're trying to pick from in boxes, you'll see most people adopting a tote process. So it makes it much more uniform, adding targets to the warehouse floor where you can then measure, find out and localize yourself. So that's really changed a lot as well in the warehouse space. But what I think is the most intriguing to me is, here we had our type, like what I say, FANUC's type of robots adopted in manufacturing and now being adopted in warehouse. What manufacturing tends to lack, in my opinion, is the developments that are happening at also an astronomical pace in the warehouse, which is the stuff you do, Jeff, with the AI from a vision, the AI from data, and the AMRs. The whole idea of these autonomous mobile robots are really a game changer. And it's I think, in my opinion, it's going to kind of come full circle and flow itself back into the manufacturing space. I know some manufacturers are slowly trying to adopt AMR technology to move, products through their factories, but there's so much potential for people on the call that are listening. There is a huge growth potential for manufacturers to take a step back now and think more intelligently about how they bring the subcomponents to the production floor, Where do the finished products go to back to the warehouse? There's so much opportunity. And right now, it's a lot of forklift traffic. And even I'll give you my other example. I'm not going to name the company, but a food manufacturer that has a completely automated production line to make a particular, let's say, juice box. I'll use that one. Completely automated. They fill it, they fill the pouch gets in the box gets on the pallet. What's not automated is getting those materials for that production line to the floor. So people still have to bring a full pallet of the labels and the packaging material. Ultimately, if they want to lean out and do more just in time, they could automate that type of flow with AMR. So that's kind of what I think is just really cool about being able to see both sides of types of operations and automation.
I wonder if it's because of the investment, right? Manufacturing's been around a long time. They started putting in these things for warehouses to learn from. Then a bunch of capital kind of fluxes in for automation and stuff. They are able to use that capital to start doing testing and R&D and stuff that maybe kicks them up. And then now maybe manufacturing can catch back up, on those pieces. That becomes interesting to me. You see this every day. I'm sure you see a lot of the challenges of why both sides, maybe in this case, manufacturing still has challenges in picking up those things as quickly. Maybe talk about some of those challenges that you see, in your given day around, how they can maybe get moving a little bit quicker.
You mean from manufacturers, or you mean just in general?
Yeah, just the challenge. Yes, just the challenges in the design and deployment of those robotics. But I guess what I'm saying is, you're seeing those challenges coming up. Maybe you can talk a little bit why those challenges exist.
Yeah, and I guess, hopefully I'm answering your question, Jeff, but I guess one of the areas I see, I've been heavily involved lately on that logistics and e-commerce space and helping those folks adopt robots. And it is a different dynamic, and it does tie into that whole AI. But some of the lessons I'll throw out there that were challenging is a customer has a problem in, let's say, the warehouse e-commerce space. They try to define the problem, and you go and you put together a solution for that problem. And then you go to their facility and you spend a day or two watching what really goes on. And that is an eye-opener, because you think, and I'll give you a use case, we wanted to do some depalletizing to do an order fulfillment off of, let's say, 120 SKUs with robots. Customer gives us their list. Here's our SKU sizes. They're all in boxes. They're all nice. Great. We got a solution for that. And then you go visit and you realize, wow, this particular SKU has 3 different suppliers. Some put tier sheets, some put corner boards, some decided to take a roll of labels and throw it and use that as a tier sheet. And until you get out there and actually look at what the real world is, you really don't know what you're up against. So it took that customer a little bit of time to work with their supply chain to say, listen, we don't need all this extra packaging materials. It's going to make it more difficult for us to automate this order fulfillment process. So please get rid of these. Let's standardize on a tier sheet type of thing. That's just one example, I guess I could give you there.
Oh, I'm sure we could fill up 20 minutes or a half hour or 3 hours on examples, but I love that one. One of the things I think about in this space, obviously at iMerit, we provide that kind of high quality data that powers the machine learning and artificial intelligence applications. And so, we care about those sensors. We care about that kind of computer vision that's powering the robotics that kind of creates that AI. I think on your side, you're seeing what kind of the AI is doing in real time on the floor. So it would be great to kind of hear from you how AI is changing what's possible within the space itself. Obviously, like you mentioned, the robots have been around for a long time, but as this AI is coming in, how are you seeing that kind of change the space? You mentioned the sensors are getting so much smaller. We look at the cars and things like that. How many sensors are on a car? It's amazing now. But how are you seeing that kind of change, on a daily basis for?
Yeah, I guess the biggest impact I'm seeing with AI is probably related to more of the AI vision applications. That's what I have the most knowledge of, where, we at FANUC have our own vision, but it's your basic 2D. You train what you're looking for, and then you go find what you've trained, right? And it was quite eye-opening to me when you're in the, order, let's say, logistics space, and you have a whole gaylord of different parcels, everything from poly bags to cassette tapes type of products and plastic and all sorts of things. If you think of anything you can order online that has to get delivered to your house, or think back to the last month of all the different products that got delivered to your house, somehow those had to be handled and had to be barcode read and get sorted so that they could be delivered to the right, destination. That's where the AI element of more high level vision has made a huge impact as what I'll call an enabler. Because I don't think if we would have that information, robots wouldn't really have a play in doing those type of tasks. So, you have to learn. And I know for everyone on this call, they're probably pretty savvy with AI, but AI is merely, I know there's multiple ways of it, but the case in this scenario is it has to learn over time. It has to see the cases of the products coming at it and update the model and say, okay, I now see this poly bag and I can discern this poly bag on top of the other poly bag or next to it and figure out where to tell the robot to go grab it and singulate it, type of thing. So that's taken some time, and it's definitely continuing to evolve. And, another piece of that is that edge case concept. I heard other people earlier.
I was going to say, we geek out on edge cases at iMerit,
edge
right?
cases.
Because, that's what we get pulled into.
Yeah, that's the huge stuff. So and I saw it firsthand, one of these systems we have you expect products and parcels to come at you that are closed and taped and sealed, but it's happens quite frequently that suddenly a box got ripped open. And I literally saw, a beer can rolling around on the conveyor. Someone was shipping a case of beer, and a lone beer can, which cannot be singulated or not be inducted into a sort system, it would cause a disaster. So fortunately, you have to build in that intelligence to say, okay, I did not expect a cylinder. Let me design this so I can recognize that this should not go into the system. Let's reject it, type of thing. So the AI, I guess, to close the loop, AI is absolutely an enabler. It's a huge enabling technology to be added to warehouses. And I see it probably getting stronger, folding it back into manufacturing and enabling more applications that maybe weren't yet being able to be automated.
Yeah, I think, one of the great areas that you're in, being in, warehouses and manufacturing, is the AI is in production really quickly. And a lot of the other kind of segments that we work in, you're in R&D for years. Self-driving cars have been talked about for a long time now. So, as you can put things into production, those edge cases come out and they have to be handled for real right now. That's something that we've been dealing with for a long time. I'm sure you guys get new ones that pop up every day that people haven't thought about. And I'm sure that, again, in the warehousing, they're going to teach manufacturing some things because they're going to see some edge cases that pop up and move that over. I guess, one of the things that comes up in these conversations a lot, came up a little bit earlier as well, is that we hear the concerns that robots pose this, major threat of, keeping jobs away from people. I know that you are kind of passionate about this subject, especially being in this space for as long as you have. Maybe talk a little bit about how you see robots versus people, how you see that kind of connecting. Earlier, someone was talking about the 3Ds. I think you and I talked about 4Ds before, so I thought that was kind of funny. But yeah, I don't know. Let's explore that space a little bit. How this is affecting the people and the good and bad of that.
Yep. No, and I think I mentioned to you, Jeff, is since I've been in this industry and doing what I do, it's not uncommon when you introduce yourself to someone, what do you do for a living? Oh, I sell robots. Oh, you take people's jobs. That is the biggest misnomer of ever, because robots definitely do not take jobs. They make jobs. That is the number one thing. And I think everyone on this call also alluded to it. Robots make your job better. And I have so many cases where, a company I start working with starts adopting their first robot, and then they grow and they add more and more. And ironically, along that journey, they're actually hiring more people because A, they got better quality. B, they got better, lower costs, which got them more business, which, helped them be more successful in what they do. And one of the best cases I have is what I would call a power tool manufacturer. They started off with a US operation here, and I think I started working with them in about 2006 when they got their first robot. Over the past, whatever that is, 17 years, they've installed well over 100 robots, but during that journey, they have like tripled the size of their factory and hired, I don't even know, I'm definitely over 300, somewhere between 300 and 500 more people. Now, yes, robots are doing the tasks like we talked about, the dirty, difficult, dangerous, and I always say sometimes it's the clean tasks where you don't want any, people touching things like food. But in this case, it's doing jobs that make people's jobs better. So yeah, I see that. Just hopefully people understand that. And then I'll give you one other case. Let's say a food manufacturer that I think the Voyage folks were talking about is, doing primary food picking. I have a customer there who, again, it is a very difficult job. You're in the cold wearing a suit because to keep meat, preserved while it's going through the packaging process, it's literally 33 degrees in there. Not a fun job. The customer that I had there gave me an eye opener where he said, we don't justify robots based on labor savings. Right now, we're justifying them on the fact that we are losing orders. They had 4 production lines to build a specific type of, product, and they could only run 3 of their lines. So they just lost 25% of their revenue because they could not produce it enough. So I think things have changed, and hopefully people understand that robots are not taking their jobs. They're just going to make their life a little easier and upskill themselves and uptrain them. So
I'm going to embarrass you maybe for a second. It's a real question for me. So you hold a bachelor's of science degree in electrical and computer engineering. You have a master's of science degree in manufacturing systems engineering from the University of Michigan, I believe. And, my kids are, in the high school kind of era and stuff, and thinking about what they're going to be doing next. And I actually take them to India with me to go tour our centers and stuff like that. And I'm sure, you've done similar things, with the people at CMU, the students who are looking at what to do next, as people are kind of coming through and thinking about where they should be concentrating to really make a difference, going forward. What do you think these students should be, what advice do you give, I guess, to these students that are moving in the field of AI and robotics? Would love to get that from you, because again, you could teach classes on this stuff. And so, hearing that from people, I think would be very helpful. Kind of your perception of it.
Yep. And I think, like was said earlier, the robotics field and the AI field in general is so vast. My best advice is do what you love. Don't force fit yourself into being a programmer if you really like to work with your hands. You know what I mean? So there's so many opportunities. Yes, you don't have to be a PhD to be in the robotics field. The brilliant people from CMUs are definitely on the forefront of coming out with some of the most unique technology, but you still need the other people that can deploy the technology and maintain the technology. And you need mechanical designers and people that are good with assembling things to put together on the factory floor. So I guess my best advice is definitely if you have any interest in the field, go for it. It's wide open, and I don't see the trend changing. I think we can't get enough people working in our field. And even for FANUC alone, most of my customers are just always looking for good robot programmers and PLC programmers and computer people and people that know machine vision. So for students, I would say if you're interested, definitely kind of steer yourself into what interests you. Don't force yourself into having to do one type of application over another, whether it be mechanical or electrical or even just being more of an applications engineer and doing simulation. And so
I think one of the things about you that stands out to me, and again, I said I might embarrass you a bit, is that, you're really an electrical engineer. I mean, that's like your background, and you're an amazing communicator. And so, one of the things I talk to my kids about a lot is that don't think that just when you get into working in tech or looking at how you can code or how you work with sensors or how you move into engineering, which my kids are very interested in, you still got to be able to communicate. So I'm just interested, I'm kind of want to get your perspective on that. Like, how much do you see communication still being such a key part to what needs to happen, even in this world of automation and robotics?
Yeah, no, that's a good point. Yeah, and I'm not a natural communicator, by the way. I was probably the shyest teenager you can ever imagine. Luckily, I got out of that box, but communication's key. On the other hand, I'm amazed at some of the young talent that we bring in and how much better they are at it than us. I think so many more young people are comfortable in front of the camera. They're comfortable. They've grown up with like what you and I are doing instead of the face-to-face, but they're very savvy. So yeah, communication, you got to know the basics, I guess. Just to get to be an engineer doesn't mean you're going to be in your little cube all by yourself designing something. Certainly people that love to write code alone, yeah, that's pretty much a solo venture, but you still need to be able to communicate with peers and what have you. And what I found interesting over my time too lately is some of the best programmers are people that loved like video games, people that thrive, the young people that are thriving.
Don't tell my kids this. Oh my God.
I know. Well, it's true. Because, like we talked about, digital twinning is huge. So if you are one of those people that loves that kind of environment, man, there might be a place for you learning how to build the simulations for these, automation cells. And there's just a lot of different opportunities.
We're getting, a little bit close on time. I want to just make sure that the audience knows, like, we love to see a Q&A question if one pops in. But, we normally always throw out this kind of help me finish the sentence type of stuff in these things. In 25 years, factories of the future will look like, they'll operate like, somebody could have asked you this question. I wonder 25 years ago if you would have answered it the way it is today. You probably would have. So now we'll just ask you, where do you see it going over the next couple decades?
Yeah. I mean, I think it's right up your alley there, Jeff, because I think it's all about the data. So you're in a good position. I mean, truly, let's face it, we're getting more intelligent about how we're going to set up our factories. And I think with the new technologies, they can truly become those lean manufacturing facilities that we've all striven to, to have. And you don't have to mass produce something and then warehouse it forever. You can be more intelligent about your supply chain and materials coming in and materials coming out. So, that's one part of, having access to the data. Obviously, adding the extra level of intelligence is truly enabling more applications to be automated versus relying on, the human to inspect, like you saw the flaw in a piece of metal, like you showed. That's an enabler. And then I think the AMRs, at least from a manufacturing, I think there's so much potential to kind of tie together those islands of automation. I think it was Pras earlier had mentioned something about, in the old days, manufacturers had these little islands of automation, and that's kind of true. But now bridging and pulling AMRs in to bridge those islands is definitely going to happen. So yeah, lights out factories, I think, could be coming. There'll still be people there running them, watching them, enjoying reprogramming and what have you. So
light dim.
I don't know if that really answers. What's that?
Not lights out. We'll dim them maybe a little bit.
Yeah, that's right. Yep. And actually, go ahead.
No, go ahead. Please.
Oh, I was going to say, actually, it is kind of ironic because we've been doing that for a while at one of our servo motor factories. Actually, can do, I think, like 36 hours lights out. But the difference is it's not a bunch of AMRs, it's a lot of conveyors. So, the other cool thing that I see is a lot less of like conveyors moving one thing from exactly point A to point B. And now you've just made that whole situation dynamic and flexible. So yeah, that's a big change I see coming.
So we got several audience questions. I'm picking one that I find fascinating. Laura, they're not asking me these questions, Laura, just to be clear. Can you discuss how you reinvented yourself over your career to continuously be at the forefront of the evolving robotics market?
Well, that's a loaded question. I don't know if I really have. I think it's just been very fortunate with connections of, people I meet, the opportunities I've had working with different manufacturers. Wow, I'm not sure if I can answer that exactly. But yeah, I kind of started off in the engineering field and moved into some project management. And I think for me personally, it was following what I love. And what I love is going to factories. I love the idea of figuring out how to automate. And that's where my niche is. So it's kind of driven me to where I am. So it's kind of like just following that journey and keying in on what gets you up, what gets you out of bed every morning.
It seems to me that you have a love for learning, and that you like to go to the factories, you like to see what's on the floor, you like to learn what's going on, and you like to keep learning. And that kind of search for that learning continues. And I've seen that just in talking to you, over the last couple of days, how you get inquisitive and want to hear and grab onto all these different things that are coming out there. So I see it in just a limited time I've met you. Another one was, what are the non-obvious fields of study that can lead to career paths in robotics? Not sure if you happen to have a thought on that for one of our students.
I mean, what I will say is I don't think you have, I know CM, you might not want to hear this. Not everyone has to go to a university even to get in the fields of robotics. And it's interesting to me, there's so many VOTEC schools that are taking it to a new level, and they have robotics and they have machine controls, and you learn, how to do SolidWorks modeling, and it's really a trade in a way. So there's a lot of different avenues, I guess. I don't know if I answered your question, Jeff.
I think
lost sight of that one.
I think it was good. No, I think it was honestly, I think it was a real answer, and I like realness. You don't have to necessarily have the biggest fancy degree at the biggest fancy college. It goes back to how we talk about reinventing yourself. You have to have a love for learning. Mm-hmm. You have to get out of bed in the morning and want to do the things that you're doing and do what you love. And I think that's an amazing message for people who are coming up today, because I don't think they hear that all the time, honestly.
And I'll throw one more thing. I was recently on a project where, kind of a new technician came on board and had been working as an auto mechanic. And you know what? That kid was brilliant. We had some challenges. We needed some stuff rebuilt. We had some tooling issues. And without blinking an eye, it takes a special person that can dive in and tear a tool apart and rebuild it and fix it. So that's a whole nother area where, you just got to find where's that skill set, and there's opportunities.
It's another question popped up that makes sense to me that it would come up. It's around kind of women in tech, the opportunity landscape for women who want to move more into the STEM fields, such as, robotics. Any, again, advice, suggestions, thoughts of what that opportunity landscape is for women who want to move into more of this, STEM field?
Yeah, I mean, it's there. I just say, if you love it, go for it, because, and I hate to even say this, but like, I distinctly remember being early in my career, actually as a co-op student, and in a room, full of all male engineers, and someone pointed out to me, wow, how does it feel to be the only woman? And I thought, I looked around, I'm like, oh my gosh, wow, I didn't even realize. I think that's where I come from. I don't think of it in that terms. You know what I mean? So as long as you just go do what you love and go learn, and don't be afraid. I think you pointed out too, don't be afraid to learn. I mean, you learn something from every single person you connect with. And if you take that and move forward, I guess whether you're male, female, or what have you, it's a great field.
How can a freshman student in college get hands-on experience beyond robotics clubs? Not sure if you have something specific for that. I'm thinking myself at the same time.
I think you would find, I guess, first, depending on where you are at college, there are so many colleges now that have practical programs like that. Even, I mean, I know for us alone, we've got 1,500 or more, everything from middle schools, high schools, VOTECs, universities, colleges that are actually using real world robotics and automation. So if you can look and see if that program's offered, if it's not, trying to think of some other solutions is, see if you can get some internships with manufacturers.
I've
Yeah,
spent
or
some time on the CMU campus, and I know some people there just build one. Just go do it.
yeah,
And
that's a good point.
I think that's one of the fun things I've seen is just getting in there and making something happen. And again, you've said it very eloquently. Do what you love. If you love it, you're going to get great at it. And so, I think we're over on time. I think what's
Okay.
amazing is we're 3 hours or whatever into these sessions, and people are still bombing questions in. Looking at I got one more. How is FANUC using AI and big data to decide on new robotic systems?
Good question. I don't know if I'm going to be able to totally answer what we're doing, because that's more on product development veins, but certainly we right now are, forming partnerships with people who are, also trying to solve the real world problems that our customers are coming to us with. So I would say, when we get challenged and we know we don't automatically have the right type of vision, we're going to go partner with a leader with an AI vision package. And same thing with data. We do some level of collecting data and making our robots more intelligent and being able to tell people when is maintenance due, but it can go to a whole new level of helping people more intelligently run their equipment. So yeah, we obviously have some things we continue to evolve and work on internally, and then others we will look for leaders in the industry and try to strike a partnership to solve a problem.
Laura, it has been amazing speaking with you today. I've had a lot of fun. Hopefully you've enjoyed it as well. I know these questions start coming out, and they're kind of fun to answer. Chris, the CMU family, really appreciate John and Dave and everybody's involvement and help putting this stuff together. I will kick it back to Chris at this point to wrap us up, but really thank you, Laura, for joining me at this fireside chat.
Yep. Thank you, Jeff. It was great talking with you. And it's such a pleasure to learn more about what you guys do.